the answer key and a clear explanation of how to do each of the problems from chapters 1.1 through 1.3 quiz. First, we always read the directions, solve the equation. That means we want to isolate the variable. That means we want to find the value for W that would make the left side equal to the right side. So when we do that, we're going to utilize the inverse operation, and we ask ourselves, one of the first questions we can ask ourselves is, what's happening to the variable? What's happening to the variable? Well, 4 is being added to it. So the inverse of adding 4 is subtracting 4. So we're going to subtract 4 from both sides, and we get W equals 8. And that is the value when we plug it in, and we can call that checking our work. We take the starting equation, and then we substitute that solution in for our variable. And we're not moving anything, we're just isolating and simplifying, we're just simplifying this left side, and we're simplifying the right side and making sure that they are the same. The answer is not 12, the answer is still W equals 8, but this is the only value for W that makes the left side equal the right side. That's what all this is about. And we're just going to do it for different situations. So we look to see what's happening to my variable. 9.6 is adding to it. So the inverse of adding 9.6 is subtracting 9.6. So we subtract 9.6, subtract 9.6. We get n left on the left side because these are inverses, so positive 9.6, negative 9.6 cancel. And we should notice that we have a negative 8.3 and a negative 9.6. So we are going to combine both of those, and we're going to get a larger negative number. So a negative and a negative make a bigger negative. Only when multiplying and dividing do we start thinking about other things. So my solution is n equals negative 17.9. That's not a great representation. Ooh, that was way too big of an eraser. I don't like the way that that negative looked. I like that. That looks way better. So notice I took the time because I wanted to focus on what am I telling my students, and students, what are you telling your teacher? You need to write clearly. It needs to be legible. I need to be able to understand what you're telling me. Here we have 10 equals x over 2 pi. We're still trying to isolate my variable, which is x. Pi is not a variable. Pi is a symbol. It represents a numeric value. So that is not a variable. What's happening to my variable is being divided by 2 pi. So the inverse of dividing by 2 pi is multiplying by 2 pi and multiplying both sides by 2 pi. Well, if I have 2 pi times 10, let's think about that, 2 pi times 10, you know what's happening between the 2 and the pi? It's a multiplication. So what we really have is 2 times pi times 10, and these are constants. So we'll make that 20 times pi, which can be represented as 20 pi. Nice and logical there. So 2 pi times 10 is 20 pi. These cancel because this is in the denominator, this is in the numerator. They're going to cancel out and leave me with my variable x. I don't have to substitute what the value of pi is. We could have, but you didn't need to. It didn't say anywhere in the directions to substitute 3.14 for pi. So I accepted either one if you wanted 20 times pi, or if you did 20 times 3.14, which is going to be, what's that, 62.8. I think I accepted that also. I didn't think. I know I accepted that. Now, notice, just give me one answer. Don't give me two. Don't say this or this. Just decide. Either give me this or give me this. No two answers, no ors, no ands, no nothing. Just give me an answer. Sound good? Good. Excellent. Okay, what's happening to the variable? Well, it's being divided by 2. So the inverse of dividing by 2 is multiplying by 2. Multiply by 2, and let's write that. Let's write that somewhere else. So we have 2 times 3/8 equals, these 2's will cancel, b. Okay? This 2 is in the numerator, this 8 is in the denominator, this 3 is in the numerator. And a lot of you multiplied 2 times 3 and got 6/8 and left it as 6/8. I've told you for the last 4 weeks to cross cancel. Numerator, denominator have a common factor of 2. 2 goes into 2 once, 2 goes into 8 4 times, and then you have 1 times 3, because 1 is in the numerator, 3, and then you have 4 in the denominator. So your answer, if you had simplified by cross-canceling, and that's what we're doing in 8th grade, that's what's expected of you in high school. You have to reduce all fractions. We have pi again. I'm isolating for this variable. 3 pi is being added to it. So the inverse of adding 3 pi is subtracting 3 pi. Subtracting 3 pi. Now, since addition and subtraction, like symbols, we deal with their coefficients. 9 minus 3 is 6 pi. The pi's do not cancel here. We're adding and subtracting, so if I have 9 pizzas and I subtract 3 pizzas, I'm left with 6 pizzas. We should notice automatically, hey, I have a mixed number. I'm going to convert that to an improper fraction. -1 3/10 is equivalent to 10 times 1 plus 3. 10 times 1 is 10, plus 3 is 13 tenths, and we know that it's negative, so I add the negative at the end. The other way you could look at this is you have, -1 3/10. So how many tenths is 1 equivalent to? Well, 1 in tenths is equal to 10 tenths. And then you have your 3 tenths. So that gives you 13 tenths. And we need to understand that that is a negative. It's going to the left. So there's a number of ways of looking. This is probably the easiest. This is what is taught later on in middle school. Early on, when you're understanding what whole values are in fractional values, probably introducing it in this manner. But the simple way is 10 times 1 plus 3, and you get -13 tenths equals x minus 1/2. What's happening to my variable? It's being subtracted. 1/2 is being subtracted, so we are going to add 1/2, add 1/2. And now we need like denominators. So we have -13 tenths plus 1/2. What's the common denominator? Tenths. So it's already in tenths. And I need to convert 1/2 to tenths. That's 5 tenths. You should be able to do mental math on those equivalencies, especially with a number like 2 to tenths. So -13 plus 5 gives us -8 tenths. So this combines to -8 tenths equals x, and we must simplify. You must simplify. What goes into 8 and 10? 2. And we're left with -4/5 equals x. Don't get your calculator out and start plugging in values and stuff like that. Just deal with the values. This is simple. This is very, very low-end fractional work. You don't need a calculator. This is your traditional two-step. Something's being added, something's multiplying. We're going to get rid of things being added and subtracted first. 3 is multiplying. We divide by 3 because that's the inverse. And we're left with x equals 5. Here, two-step. This is hidden a little bit. This is interesting. We still have something being subtracted, something being divided. We're going to get rid of the addition and subtraction first. And then 4 is being divided, so we multiply by 4. And you're left with f equals negative 16. When we multiply a negative times a positive, it is a negative. And that's my answer. Now, this is a great question because this is a little bit different. We have Chewbacca. No, that wasn't the machine in my classroom. That was my voice. Yep. But this is a vinculum. And a vinculum is very, very special. It's something that is like it's like a grouping symbol. And so we need to understand that this statement really says q minus 7 divided by 3 equals 8. We can look at it as parentheses q minus 7 over 3 equals 8. That's probably the best rendition or looking of it. And we can't get to this q and the 7 because Chewbacca's here. That vinculum acts as a parenthesis up here, so I can't get to this stuff. So I got to get rid of the 3 that is dividing. The inverse of dividing 3 is multiplying by 3. So I'm going to multiply both sides by 3. That 3 in the numerator cancels with 3 in the denominator, hence why I did it. And we get q minus 7 equals 24. And now look how nice this is. Add 7, q equals 31. Why didn't I do that in this problem? Well, because that's not a vinculum. It's not affecting each other. Why don't I multiply by 4? Well, you could have, but you would need to multiply everything by 4. So you have to notice the difference between question number 8 and question number 9. That is so important. You have to pay attention to the details. This is still a multi-step. We're going to combine like terms. We can combine them because they're on the same side of the equal sign. We have 9z and negative 4z. How did you know that 4z was negative? Because there's a negative sign next to it. That gives me 5z minus 5 equals negative 5. Now it's a two-step problem. We're going to get rid of addition and subtraction first. 5z equals 0. Divide by 5, z equals 0. We must simplify 0 over 5. That's not simplified. And 0 can be an answer. There's a number of students who gave me all real numbers or no solution or whatever. There's only one solution. And that number that can plug back in here to make the left side equal to the right side is 0. So we can tackle this problem in two ways. I'll show it in both. So a high school student would, this negative 4 is multiplying. I can't get inside here. I can't get to this positive 12 because Chewbacca. Yep, that was me again. I know. I should go out. I should go to Disneyland or wherever. Yeah, Disneyland, Star Wars, and audition for Chewbacca. So negative 4 is multiplying this quantity. So I'm going to divide by negative 4. Now Chewbacca goes away, and you're left with a minus 12 equals 36 divided by negative 4 is negative 9. We'll add 12, and we get a equals 3. The other way you could have done this problem, this is more of an 8th grade method, more of a middle school technique, is you're going to distribute. Distributing is the other way to get rid of these parentheses or Chewbacca. So negative 4 times a is negative 4a. Negative 4 times negative 12 is positive 48 equals 36. And now we have a two-step problem. Get rid of the addition and subtraction. Negative 4a equals negative 12. Divide by negative 4. Divide by negative 4. A equals positive 3. So it doesn't matter. A little bit more work over here opposed to much more efficient here. I don't care which way you do it, that you don't get minus points for doing distributive property. It just takes you 1 or 2 steps more. So this is going to happen again. If you go back to the video of me doing this in the extra practice, I told you be careful of this problem. You had it in homework, you had it in extra practice, you had it in puzzle time, you have it in just about every single worksheet that I provided you, that you cannot add and subtract before multiplication, because we're just simplifying this left side. We're not moving things, we're just simplifying. So I'm going to show you the first technique of doing this. So we can distribute the 3. So this becomes 7 plus 6g minus 18 equals negative 29. I just distributed 3 times 2g is 6g, 3 times negative 6 is negative 18. I'm going to combine like terms first before I start moving anything. 7 and negative 18 leaves me with negative 11. I have a positive 7 and a negative 18. That's not 18, that's negative 18. I look to the left to see if anything is positive or negative. Equals negative 29. Now it's a two-step problem. We'll add 11. 6g equals negative 18. Negative 29 positive 11 gives me negative 18. Divide by 6. And we get g equals negative 3. A negative divided by a positive is a negative. Here's how a high school student would do this problem. 2g minus 6 equals negative 29. They would subtract 7 first, because it's adding and subtracting this quantity. That gives me 3 times the quantity 2g minus 6 equals negative 36. Negative 29 and negative 7 leaves me with negative 36. Now, I still can't get to my g or the 6 or the 2 because Chewbacca, so I'm going to divide by 3. And that gets rid of it, so now Chewbacca goes home. We're left with 2g minus 6 equals negative 12. We add 6 to both sides. You get 2g equals negative 6. Divide by 2. Divide by 2. G equals negative 3. That 2 kind of looks like a 3. So let's make sure that that looks like a 2. And we notice it's the same answer as the left side. However you want to do it. Whatever way is easiest. All right, now we got decimals. Decimals are not harder. We are not going to add these two. We're not going to move this over because there's nothing for us to combine it with. We have this n in here, and we can't combine it with here with this n yet, and we can't combine these because of the parentheses. So in this problem, we're actually going to use distributive property. That is the high school method, distributing. So there is no faster way to do that. 25.8 equals 1.2n. Now 6 times 12 is going to give me 7.2. 7.2, because 6 times 12 is 72, with the decimal moves the decimal there. And 0.6 times negative 3n is going to give me negative 1.8n, because let's think about it, 6 times 3 is 18, and I got that decimal place. Now, I'm not moving anything, I'm still simplifying on the right side first. So I have 25.8 equals, I have a positive 1.2n and a negative 1.8n gives me a negative 0.6n plus 7.2. I have more negatives than positives. And now this is a two-step problem. Minus 7.2 minus 7.2. That's going to give me 6. I got to borrow. That's 8, bring down the 1, 18.6 equals negative 0.6n. Negative 0.6 is multiplying n, so I'm going to divide by negative 0.6. I know my answer is going to be negative. Any positive divided by a negative is going to be a negative. So I can put that sign there. Now I got to divide 18.6 by 0.6. There's two ways I can do it. I can do it the easy way because I am very competent in using a calculator. So I'm just going to click that in and I get 31. And I remember that I have a positive divided by a negative. So my answer is going to be negative 31 equals n. If I needed to do it out in hand, you have 0.6 divided by 18.6. We move the decimal point one place, move the decimal point one place. That turns this problem into 6 divided by 186 with the decimal point here. And 6 goes into 18 3 times. Bring down the 6. 6 goes into 6 once. And I would have gotten 31. So that's not crazy math. You don't need a calculator. This is basic. This is what is expected of you. Good one, right? We can do this in a number of ways. Cross product is going to be the easiest way for you to do this because it's straightforward. Something that you should be wary about is the fact that the variable is in the denominator. There were some students that did not notice that. So we have 9 times x equals 5 times 63. I'm not going to multiply 5 times 63. I'm going to divide by 9 here because I'm isolating the variable. So that gets me x, and I'm still not going to multiply 5 times 63. I didn't do that because I know that 9 and 63 have a common factor. 9 goes into 9 once. 9 goes into 63. Not 7 times, Mr. Mack. Yeah, 7 times it does. And 5 times 7 is 35. So I got my answer without a calculator. So x equals 35. Pretty good? Yeah, should be. Let's cross product again. Yes, I know you could have solved it by multiplying by 2, but we're going to cross product because we're going to show that we can still do it. Let's embrace it. We have 9 times m equals 3 times 2. 9m equals 3 times 2. Why didn't you multiply it? You could have, but I again notice that I have common factors here. I have a 3 and a 9, common factor of 3, common factor of 3. 1 times 2 is 2, and then we have 3 in the denominator. And I wouldn't have given you 6 over 9. A lot of students gave me 6 over 9. A lot of students gave me this ugly number, 6 divided by 9. Gave me that. And they literally wrote out all those 6s. And insult to injury, they also wrote out the 7. The 7 is a rounding. All the calculator do is looking at this and rounding this last digit, whether it round up or down. In this case, there was a 6 next, so of course it rounded up. You need to understand what all this means. Don't use a calculator unless you know how to use it. So it's going to come out. So that's not necessary. This is the only answer you should be giving me. Now, if you did want to give me a numerical answer, this is equal to this. And this is equal to this in notation. You need that. What's repeating? There is no 7. You will never see a 7 in this answer. So this is the proper notation if you wanted to give me something, but you shouldn't. But you should know that these two are equivalent. 2/3 is equivalent to 0.6 with a repeating sign. The right triangles created by each object and its shadows are similar. The height of a person is 5 feet 9 inches. The height is 5 feet 9 inches, okay? And their shadow is 5 feet. So they have a shadow that is 5 feet long, okay? if a totem pole has a shadow of 40 feet, what is its height? So here's my totem pole. Let's put some wings on it. Maybe a beak, maybe some eyes, maybe a nice mouth. So this totem pole, we don't know how tall it is, but we know that its shadow is 40 feet. Cool. So now we can write a ratio. We can write a ratio of the person and the totem, and we can put it in a ratio. Let's do height to shadow. So this person's height is 5 feet 9 inches, and its shadow is 5 feet. And that is going to be similar, so they're equivalent to the height of the totem over the shadow of the totem. Now, we are in feet and inches, so we can either convert to inches, so 5 feet 9 inches, 5 feet is equivalent to 60 inches, and then plus the 9 inches, because 5 times 12, 12 inches in each foot, 5 times 12 is 60, so that's going to be equal to 69 inches, and we know that 5 feet is equivalent to 60 inches, and then x and 400, so 400 feet is equal to, well, there's 12 inches in each foot, and we have 40 of them, so that's 480 inches. So this is one way that you could have done it. Notice that this is in inches. This is not in feet. This is in inches and feet, feet, feet. So the other technique you could have done is you could have converted 5 feet 9 inches into a fraction, which is 5 and 9/12, or 5 and 3/4. So knowing that the decimal value of 9/12 or 3/4 is 0.75. So if you wanted to go stay in feet, so you could have had this equation, and we know that this is in feet. So either one is fine, but you had to write 5.75. You know what 5 feet 9 inches isn't? 5 feet 9 inches is not 5.9. That is out of tens, that's 9/10. This is 9/12. Hence why those are not equal to each other. 5/9 is equal to 5.75 as a decimal. So now we could do cross product. In either one we can go, I don't care which one you did. Let's do feet. So if we do feet, we're going to have 5.75 times 40 equals 5 times x. We're going to divide by 5. Divide by 5. Mr. Mack, why didn't you multiply those? Because that's going to produce a big number. And I see that these are factors of each other. That 5 goes into 5 once and 5 goes into 48 times. And that's a whole lot easier to multiply. So off to the side, I'm going to multiply 5.75 times 8. That's 40. 7 times 8 is 56, plus 4 is 60. 5 times 8 is 40, plus 6 is 46. 1, 2 decimal places, 1, 2. So my decimal goes there, and I get 46 equals x. Now, is it 46 feet? Is it 46 inches? That depends on which one I used. Since I used the feet one, it's going to be 46 feet. If I use the other formula, if I use the inches formula, then I would have gotten my answer in inches. This one I cannot use. That is, you can't cross multiply these two. This is inches and feet, and this is feet, so those are unlike units. Really important for you to understand that concept. Oh yes, here we go. This is my favorite. This is what I've been waiting for. The metric system. The metric system. Let's do system. Metric system, super easy. King Hector died, unfortunately, drinking chocolate milk. Okay? So this stands for kilo, hecto, deca, units, meaning meters, liters, and grams. It's the unit measure. Deci, centi, milli. And we're just going to move in from all this. Each place is a base 10. So if you move from K to H, you're moving the decimal one place or timesing by 10, two places timesing by 100, three places timesing by 1,000. And that's the same. If you go from hecto to deca, if you go from deci to centi, it doesn't matter where on this graph you move one space, that's going to be 10. If you're moving to the right, if you're moving to the left, you're getting smaller. Okay, you're multiplying by 0.1 or dividing by 10. If you move two places, you're dividing by 100. But I wouldn't even get into the hundreds and non-hundreds and all that stuff. I'm going to show you, just going to take this decimal, 0.6, and then we're going to look and see, what are we starting with? We're starting with kilo, and we're moving to centi. So we're going from kilo to centi. How many places? 1, 2, 3, 4, 5. So we go 5 spaces to the right. Let's take this decimal point and we're going to move it 1, 2, 3, 4, 5 spaces to the right. And we're going to add zeros in there. And our answer is going to be 60,000 centiliters. It is as easy as that. What? Are you kidding me, Mr. Mack? No, I'm not kidding you. Let's take another example. Let's do 3.6. Let's do decigrams. And let's see how many decagrams. Deca is going to be DA. That's the difference between decagrams and deci. Big, small. So I'm just going to write this. King Hector died, unfortunately, drinking chocolate milk. What am I starting with? I'm starting with deci, and I'm going to deca. So I'm going to go 1, 2 spaces to the left, 2 to the left. So I write my number, 3.6. I almost tried to erase with my hand. Let's do it in 3.6. And now we're going to take that decimal point and we're going to move it 2 places to the left. And then we're going to add zeros. And so it's going to be 0.036. As easy as that, kids. This tells you the direction that you're going. You just have to focus on what do you start on and what are you going to. And you have to understand that what each one of these equals. Kilo, hecto, deca, units, meters, liters, grams, deci, centi, milli. And just follow the bump. Easy as that. Hopefully that helps you tremendously and you're going to feel super confident. Last one, super good problem. You had multiple examples in your homework. You had multiple examples that you had access to. And I was kind of disappointed on how many students did not take the time to work on this. Yes, it's hard. Yes, it's confusing. But neglecting it is not how you deal with difficulty. You have to address it. You have to be honest with yourself. And even if it means that you have to make some sacrifices, like not going to volleyball, not going to football practice, not doing 2 sports in one day, and addressing and staying after, asking for help and extra help working with your tutor, working with your parents, your older sibling, your best friend, your next door neighbor, whoever knows how to do this, to work with it. And doing it one time is not enough. You're going to have to practice this 10 times, 20 times, enough times that it becomes rote, that it becomes a habit, and you know how to tackle it. Once you see this question, bam, you're already starting. So we have a mako shark, okay? And its unit, its speed is 19.5 feet per second. That's a unit rate. And then we have a blue tuna. And that blue tuna can swim at 72.5 yards per minute. That's a unit rate. We can't compare these because they have different units, feet per second, yards per minute. So I got to convert one of them. I got to convert the feet per seconds to my yards per minute, or I need to convert my yards per minute to feet per second. I'm not going to convert both of them. I just got to do one of them. I saw lots of people finding some weird middle ground. I saw them converting both to opposite ones or whatever. I'm just going to convert the mako shark. I'm going to convert feet to yards and seconds to minutes. So I'm going to do that. And I'm not changing. I'm not touching this. I'm going to keep this value. I don't have to convert it. It really wasn't that much work. All you had to do was convert one to a common unit. So I'm going to convert feet to yards, seconds to minutes. So I'm going to do my first conversion box. And I'm going to convert feet to yards. So I think, how can I get out of feet and yards? Is there a conversion box that understands feet to yards? Yeah, 3 feet equals 1 yard. Now, the question is, do I put 3 feet here and 1 yard here? Or do I flip it and do 1 yard here and 3 feet here? Let's think about the logic of it. Why would this be correct? This is correct because it cancels. This in the denominator cancels with this in the numerator, and we're left in yards. We want to get to yards. If we had it the other way, which a lot of people did, they were multiplying things by 3 feet. Well, I need to go feet to yards, and there's 3 feet. No, 3 feet to 1 yard doesn't cancel. That becomes squared feet because we're multiplying this times this, numerator times numerator. That would not work. So that's why that was incorrect. That's why you got the wrong answer. It doesn't even make sense. It doesn't cancel. So if I have feet in the numerator and need to get rid of it, then I need to put feet in the denominator. And I know that 3 feet equals 1 yard, and we like that. It cancels out of yards. Or it cancels out feet and we're into yards because that's what's left. Now I need my I need my second conversion box because I need to get to yards. I'm good to go. And now I need to go from seconds to minutes. So seconds, where's seconds in the denominator? So where in my conversion box does seconds need to go? If it's in the denominator, where is it going to get canceled? If it's in the numerator. And then I know seconds to minutes. It's 60 seconds, 1 minute. What cancels? Seconds in the denominator, seconds in the numerator. And now, instead of multiplying, I'm looking to cross cancel. Do I have something in the numerator that will cancel with something in the denominator? Yes, 3 and 60, they have a common factor. 3 goes into 3 once, 3 goes into 60 20 times. And now I'm going to multiply across. 19.5 times 20 is going to give me 19.5 times 20, 0, 10, 18, 19, 3, 1 decimal place. So that gives me 390. What's my unit up here? Yards over, I have 1 times 1 times 1. What's my unit? 1 minute. And voila! Hey, yards per minute, yards per minute. Look how simple this page looks. I had so much writing, so much detailed writing, and it really wasn't that hard. So, which one travels faster? The mako shark. It can travel 390 yards per minute, opposed to the bluefish tuna that can only travel 72.5 yards per minute. So, my answer is going to be the mako shark is faster. Anytime we have different units, we have to choose, or two situations where we have different units, we have to choose which one we're going to convert to. We start with this and we're going to go to this, or we're going to start with this and go to this. Doesn't matter. Hopefully this helps you for your review. We have our reassessment on Wednesday during BPL. Come and talk to me if you have any questions. Good luck.